So let's start with the interference. So the other day I explained what interference is, and I said interference is one property of waves. After talking about the diffraction, which is the spreading of waves when they pass through an aperture or barriers, refraction, which is the bending of a wavefront when it travels from one medium to another of different refractive index of a wave. We are done with reflection. You read more about it. Well, with the
Sir,
interference,
please give me the definition of a wave.
definition of what?
Reflection of a wave.
Is the change in direction of the wave. Is a change in direction of a wave, or is a change in direction of the wave. Is a
This is how.
change in direction of a wave when it encounters a hard surface. Change in direction of a wave when it encounters a hard surface. The change in direction of the wave when it encounters a hard surface. When it encounters a hard surface without a change in its velocity. Without a change in its velocity, frequency, or amplitude. Are you okay? I want us to finish the first
Yes,
part
sir.
of waves today. So let's look sharper. Okay, so we are talking about the interference. So I said the interference is the superposition of two or more waves, or of two waves of the same frequency and amplitude. And the other day I explained that when you dip two balls or two stones in water or in a tank of water, you realize that each forms ripples. You know, when I say ripples, the other day I do it. Each forms ripples. I hope you remember I do it on the board. So if this is the water, if here is the water, when you drop it into it, they all form ripples. So you are going to get some ripples here. You're going to get some ripples here, and so on and so forth. You're also going to get same. But because of how they are, they might cross each other. The ripples might cross each other. Now, when that happens, we call that there has been a superposition of waves. And so there's maybe source A, source B. And so there's a superposition of waves. You draw it well if you want to draw it. I think you should have listened. So the two regions overlap. And when they overlap, we are saying that they are said to be superimposed. They are said to be superimposed, or interference has occurred. They are said to be superimposed. So we are saying superposition of two waves of the same phenomenon, frequency, sorry, and amplitude produces phenomenon which is called the interference. And the other day we explained what interference. I said all these things, and I told you that it is normally governed by the law of superposition, where I stated that when two waves are, what do you call it? I said uh, it states that when two or more waves pass through the same medium at the same time, the net displacement of any point in the medium is the sum of the displacement that would be caused by each wave alone in the medium at a time. So I said that the other time, and I said that as a convention, all the troughs are assigned a negative. So all the troughs are assigned a negative, and all the crests are assigned positive. And so let me just demonstrate the crest and the troughs here. So yeah, if you are using, when you normally talk about crest and troughs, when you are talking about the transverse, transverse waves. So when we talk about this thing, you said last week we ended at seismic waves. Uh,
Yes, sir.
then last week you went
Yes, sir.
following. Then last week you went following because the whole of last week, right, we didn't do 6 week. We did that a week before, and I told you to go and read about it. I remember last week we did a lot of calculations on the amplitude and the rest. Or you don't remember?
Sir, I remember the calculations
Yeah, that's what we did last week. The seismic
because
we did.
everything.
You said the seismic we did that last 2 weeks, and I told you to go and read about it because it's reading. I wouldn't go much details into that. So last week we looked at the terms which is used in describing a wave, We looked at the amplitude, the period, the phenomenon, and those things. From there, I calculated the progressive wave equation. Do you remember? Eh?
Yes, sir.
Or you forgotten?
Yes, sir.
Then that means you weren't following last week, or you didn't go and learn again. We did the progressive wave equation. Do you remember?
Sir.
We did
Yes.
the progressive wave equation. We solved questions on that. The speed of radio wave is so and so and so. Find the frequency and the rest. You solved yours, I solved mine, and so on and so forth. And from there, we said we are going to look at some properties of light. And I told you that properties of waves. We spoke about the light can be reflected and so on. Wave can be reflected, refracted, and so on. And I told you that normally light is also a wave, so they use the same principle like light. You get it? When we talk about reflection, when we talk about refraction, and so on and so forth. And we spoke about interference. We go to interference. We are just about doing stationary. Our time was up or network or something. Please, do you remember? Do you not remember?
Yes, I did not write the characteristics and distance. That's why I was confused.
Sorry.
Because everything we do, I write it.
Because I remember the other day you made me repeat this thing, the law. You told me you were writing it. Do you remember? The law, this thing, the interference, this thing. Do you remember? Do you have it in your book? You made me repeat it like 2 or 3 times.
Yeah. I'm glad.
So,
Yes, sir.
so that is it. So make sure anytime we teach you, make sure you listen so that we don't always have to go back. So that is it. And then anything I tell you to go and read, you go and read about it. If you don't understand anything, when you go and read, you come and ask me. So I read this, I didn't understand. What does it mean? Then I do my best to also.
I've looked for wave in the attack.
Uh,
And no, it is not in volume 1. And the volume 2 too is in school. So me, I thought so.
don't worry. That's what I'm teaching you. So you just pay attention. And once you don't understand, you let me know. Some of the things you can just Google online, like the seismic waves. They are just reading this thing. You just read and broaden your horizon. That is all. They are basically theories, so you don't have to listen. With the mathematics and everything, I'll teach you because that one you have to be taught. With the other ones, if I feel like teaching, when I think it's necessary, I'll teach. So we were talking about the interference. So we said that, and I said normally the troughs are normally the upper ones. They are normally assigned with the positive. If you look at this, and these are in the negatives. These are in the negatives.
So I thought the other the negative too.
You said, sorry, the troughs are assigned negative. So these are the troughs and these are the crests.
The troughs were rather.
Sorry. The troughs are negative and the crests are positive. Sorry. So these are the crests and these are the troughs. And normally, so that is it. You have it. And from here to here is the amplitude, the maximum displacement. The amplitude. This one is also another amplitude, maximum displacement. That is all. And so that is it. Now, when two waves are superimposed in the same place, when the two waves are superimposed in the same place, example, when we have crest on crest or troughs on troughs, we get the lines of increased disturbance or constructive interference. So when you have two waves, so there's a two waves. When you have two waves like this, oh, when you have two waves like this, and you have something like this. You realize that the diagram, they are basically the same thing. So when you have two waves, I just brought the addition here to just mean that the two waves are superimposed, but they are the same. You realize that the crest is on the crest and the troughs are on the troughs. That's how we say it. So when you have something like this, look at the diagram, you realize that they are the same. So when they superimpose or when they overlap, then you are going to get something like, yeah, you are going to get the same thing. So you are going to get crest on crest, troughs on troughs. So it was still going to be the same diagram. So you are going to get something like this. Then you don't have a key line, sorry. So that will be 2A.
Cassava.
We're reading a key line. Uh,
So inter-science. Inter-science.
I'm talking about elective physics. So when you have something like
But I
this,
said the Atake is more trusted.
it's more trusted. Now you since when did you start learning physics that saying Atake is more trusted? Uh, all of us we use Aquila. Aquila came way before Atake. So what makes you think Atake is trusted? Maybe you are okay with Atake. That is some people are okay with Atake. Like the way initially I didn't like approaches, but now I like approaches series a lot, even more than Aquila. But Aquila has always been this thing. Maybe you like this thing, but it doesn't mean Aquila is not trusted. It is. You get it?
Yes, sir.
Yes, that most of you guys like the this thing. I'm used to Aquila, so that is it. So when you have something like this, we call it constructive interference. Constructive interference. When you have crest on crest, crest on crest, and trough on trough, it means that when you have crest super, what do you call it? Being super crest being overlapping and the troughs, the two crests overlapping and the troughs also overlapping, and you're going to get a constructive, what do you call it, interference. However, when you get a crest overlapping with a trough, a crest overlapping with the trough, and a trough overlapping with the crest, then you're going to get a destructive interference. Hmm? Are you getting it? So it's as if getting two A's and this, and they are all this thing. So there's a constructive interference. We call this constructive interference. Constructive interference. Constructive interference. You add the interference. Now uh when you have something to like this, and it's added to something like this. You have something like this. You know, just know that here are the positives. This one are the positive, and then that one are negatives. Already know. Now when you have another one like this, you realize that this is on this. When you add it, this will be on this, and this will be on this. So when this be on this, if this positive and this negative, they will cancel out. This negative and this, but they'll cancel out. So here, the amplitude will be zero as compared to here where the amplitude will be 2A. Here, the amplitude will be zero. Please, do you get it? Hmm.
Yes, sir.
Or if you don't understand, just let me know. So here, this one we call it. This one is zero amplitude. So here, this will be the outcome. Then this will be to be zero amplitude, zero amplitude, zero amplitude. It is more or less like here, the positive are on the positive, or the positive and the positive are adding, and the negatives and the negatives are adding. So then we are going to get positive 2A and negative 2A. We are going to get something like that. And so that means the crest will be positive 2A, the trough will be negative 2A. This will be the negatives and this will be the positive. But however, when you get something like this, where this and the first one is doing the addition, looking at the diagram, then you just bear with me that the positive and the negative will cancel out. Positive and negative will cancel out, will give you zero. Positive and negative 2 will give you zero. So here you are going to get zero amplitude. The amplitude will be zero. Do you get it now? So this we call this destructive
Yes, sir.
interference. There's destructive interference. So we call this. So we have two types of interference. We have the destructive interference and the constructive interference. Destructive. So with the constructive, normally you have when you have two crests on each other, so crest on crest or trough on trough, then that one a constructive interference is formed. When you have what do you call it? Crest on troughs and troughs on crest, then that means destructive interference. Destructive. So that's the two interference we have. So this we see that normally when the two waves, so here we are talking about wave here, when the two waves are in superimposed out of phase, when they are superimposed out of phase, so here they are superimposed out of phase. So this phase is different from this one, but when they join, then that means they are superimposed out of phase. But when you get here, this and this are in the same phase. So when they superimpose in phase, not out of phase, then a constructive is formed. When they are superimposed out of phase, then a destructive is formed. And so here we are saying that crest on here when you have crest on troughs, then they are superimposed or they overlap out of phase. You get it? Now when it is positive on positive, crest on crest, trough on trough, then you are saying that they are superimposed in phase. Are you getting it? I saw your answer. Listen. So when you have
The
this thing,
crest on crest and trough on trough. So that means positive, because when you're constructing it, by all means there will be a positive, the top part will be positive and the down part will be negative. So how can you get crest and then another crest beneath it? That's what I don't understand.
oh, but you have the we are talking about this is crest and this is crest. So when we are saying that when you have two waves, there's a crest and there's a crest, and the two waves superimpose. When we say superimpose, when they overlap, and they overlap in such a way that the crest and the crest meet or superimpose, then that means they are going to get a constructive interference. Now, when it happens that the crest, when they superimpose or when there was overlap, this one came on this one instead of meeting with this, then that means it's destructive. When that happens, they cancel out. So you realize that the water, if you are using the water principle, then here you realize that the water will be calm. There won't be any like ripples because they've cancelled out. So you wouldn't be seeing ripples and so on and so forth. You get it in the destructive because amplitude is zero. There's no maximum displacement because they've cancelled out. But here, when it happens and you see the ripples and so on and so, then you realize that there is what do you call it? There's a constructive interference because the crest and the crest are on top. So definitely there are a lot of ripples moving and so on and so forth. Do you get it now? That's how come you realize that the diagram, this and these two diagrams are different. You realize that this and this, see, they are the same diagrams, but here they are different diagrams. This is here, but in this case, it's here. So when they add, we are seeing that they are out of phase. That means they are not in phase. And this one, they are in phase. These two diagrams are the same. It's like getting A plus A. This is how this diagram is: crest on crest and trough on trough. Then when this one is out of phase, this diagram is different from this diagram. This first diagram starts with a crest and a trough, but however, this diagram starts with a trough and a crest. So there are two different diagrams. So when you get the two of them, you are saying that they are said to be out of phase. So they are going to cancel each other. So you are going to get zero amplitude, and then that will lead to a destructive interference. So if we are using water, the water will be calm. You get it? The water will be calm at that point when because the waves will cancel each other, so the water will be calm. Hmm? Do you get it? Hmm? Please, do you get it? Ruben,
Yes, sir.
do you get it? Huh?
Yes, sir.
Good.
Yes, sir.
Okay, okay. Don't worry. So let's do stationary or standing waves. Can I please clean the board?
Yes, sir.
So in last week's class we studied about the progressive wave. Today we are going to do standing wave. Stationary, standing wave or stationary wave. Stationary waves. I'm coming in. So when a stationary wave is a wave obtained when two progressive waves. Is a wave obtained when two progressive waves of equal amplitude and frequency are traveling in opposite direction and combined together. So it occurs when two stationary waves, two progressive waves. The other day we studied progressive waves, and I remember exactly that I explained what a progressive wave, and we studied what a progressive wave is the other day. And we said that the progressive wave is a disturbance or a pull that conveys energy from one point to another without the transport of the matter itself. I hope you remember we studied that the other time. In other words, we call it traveling waves. A wave that conveys energy from one point to another without the transport of
Yes,
the
sir.
matter itself. And we said that we have two main types of progressive waves. We said we have the transverse waves, we have the longitudinal waves. I hope you remember. And we studied that the other time. Yeah, we are talking about stationary waves. And I said that before a stationary wave can occur or can be formed, there should be the traveling of waves from both sides. That means the other day when we did the progressive wave equation, we said that there's that one which is traveling from the left to the right, and that which is traveling from the right to the left. The wave is traveling from the left to the right. Another one, the wave is traveling from the right to the left. And we realized that they were both assigned a positive and a negative. And the other one traveling from what they call it, the left to the right was I think negative, and the right to the left was positive. I hope you remember. Hmm? I hope you remember.
Yes, sir.
Yes. So here, the stationary wave is a combination when two it's obtained when two progressive waves of equal amplitude. So they must be of equal amplitude and frequency, and they should travel in opposite direction and combine together. So when you have A and B of same amplitude and magnitude traveling in the opposite direction, they combine together. Then we are saying that when they combine, then we are saying that a stationary wave has been formed. A stationary wave has been formed. So when you have something like this, just explain a diagram. Okay, so we have something like this. Here we are seeing that two waves, two waves superimpose, or two waves meet at a point. So realize that here two waves are meeting at a point, one from the other side and one from the other side. So one from the positives and one from the negatives. And they meet at a point. So you can see that they meet at a point. Then as they are traveling waves, you get it. But when they meet at a point, they form a stationary wave and so on. I'm going to explain it. So here the so so when we have this, the ones with what do you call it? The the deep ones, the ones I've made it deep, they are called the incident waves. So they incident. They are called the incident waves. And the one with the what do you call it? The faint broken lines are called reflected waves. They are called reflected waves. Reflected waves. And when we talk about incident, I know you know. These are called reflected waves. Reflected waves. Reflected waves. So now when you have this, we have something called the wavelength. I explained this the other time. Now, half of this, you realize that from here to here is a full wavelength. I hope you know that. From this point to this point is a full wavelength. Likewise, from here to here is a full wavelength.
Yeah.
Yes. So when you have from here to here, or let's say when you have half of this, when you have half of this, that means from here to here, the wavelength is 1/4. I hope you agree with me. That'll be 1/4. So that will be this will be your wavelength. The wavelength will be wavelength all over 4. That means 1/4 of the wavelength. That is half of it. Then you know, because from here to here is 1, and that means from here to here will be 2. That is half of the 1. And so from here to here to will be uh, half of the wavelength. That means 1/2. And definitely from here to here will be the full wavelength. We did that the other day. So this one is the full wavelength. Please, I hope you get it. Now we have something called antinode and node. The antinode is denoted by A. Antinode, AA or AN. Now I'll do it AA. And what they call it, the nodes, we denote them by N. Now I'm going to, on this diagram, I'm going to show you where the antinodes are and what the nodes are. Now the node is a point on the stationary wave. So the full of this is a stationary wave. That's a combination of waves meeting at a point, traveling from both directions and meeting at a point. That's how come we have some faint and we have some listen. It just means, and the arrows what from this.
So what I'm trying to say is that from the yellow place to the other yellow place, isn't it a wavelength?
From which yellow place?
Because this thing is not showing that.
Which this thing? From here to here.
From, from the
From here to here. From here to here. Everything from this side to this side, they are all wavelength. We are talking about distance here. But here we are talking about the wavelength in terms of, is this one wavelength? Is this two wavelengths? Is this half of the wavelength? Is this a full wavelength and so on and so forth? That's what we are talking about. You get it? So we are saying that from here to here is a full wavelength. That means one
okay.
wavelength. Is a full wavelength. So that means if from here to here is one wavelength, then that means from here to here will be half of the wavelength, and from here to here will be 1/4 of the wavelength. It means that from here to here, if you want to consider from here to here is 2 wavelength. That means the whole of this from here to here will be two lambda, which is 2 wavelength. Are you getting it? Hmm? Do you get it? So here, we have the node and the antinode. The node and the antinode. Normally denoted by, the antinode is denoted by AA. The node is denoted by NN or N. Now when we say node, is the point on the stationary wave. The whole of this is a stationary wave where you have two progressive waves combining or moving from opposite direction and combining. Now, the wave, what do you call it? The node is a point on the stationary wave where there is no movement of the medium. So when you look at the stationary wave, when it gets to this point, there's no movement. When it gets to this point, there's no movement. When it gets to this point, there's no movement. So these points are called the nodes of the wave. The nodes of the wave. The nodes of the wave where there's no movement. The point on the stationary wave where there's no movement. Now, the vice versa is the antinode. The antinode is what do you call it? The point on the stationary wave where there's maximum movement. So you realize that here there's maximum movement. This point, there's maximum movement from this side. This side, there's movement from this side to this side. There are movement. So on all that side, we label the A. This side, there's movement. There's movement of the wave. It emits the wave from this side, from the opposite side, where it meets and there's no movement. We call that place node. Where there's movement, we call the antinode. So that is it. So where the antinode is a point on a distance where there's a lot of there's a lot of movement. There's a lot of movement. So that is it. So the distance between the node and the antinode. So if here is a node and here is the antinode, the distance between the node and the antinode, here too is the node. So the distance between the node and the antinode here is that lambda over 4. That's a half of this thing, 1/4 of the full wave, full wavelength. Sorry. So from here to here is what do you call it? The distance between the node and the antinode. The distance from here to here to is 1/4 of the wavelength. Now the distance between nodes and nodes is 1/2. The distance between nodes and nodes is 1/2. Consecutive nodes. So the distance between here and here is 1/2. That's it. 1/2 of the wavelength. The distance from here, the nodes and nodes is 1/2 of the wavelength. I hope you agree. And also the distance between this and this two. The difference between two A's. Two A's is also 1/2. Please, do you understand? Do you agree or disagree? Ruben, talk to me.
So I say yes.
Okay. Are you done drawing? Let's do the stationary wave equation. We've done the progressive, so let's do the stationary wave equation. Can I play clean? Are you done? Oh yeah, writing.
So I'm done.
Oh, okay. So let's do
So I'm done.
stationary wave equation. Good. So the stationary wave equation, when we talk about the stationary wave, we said that it is formed when waves are moving from both directions, from right to left, and meeting the one moving from left to right. And so we are going to have two equations, and we are going to add them. So if you have, let's say, let y1 represent wave moving from the left to right, then we are talking about a sine, amplitude sine, into brackets 2 pi 2 pi vt as 2 pi x all over. So this one represents wave which is traveling in the x direction, but traveling from left to right. And we should also have one y2 also represents that's traveling from right to left, which is positive. So we are saying that they should have the same equal amplitude and frequency. So you have this. So here, so according to what they call it, the wave distance, we are going to see the resultant will be the addition or the summation will be y is equal to y1, which will stand for the stationary wave. Please, I hope you agree. Because we are saying that the stationary waves counts when you have two waves coming together. So y will be equal to y1 plus y2, where we have y1 is a sine 2 pi vt all over this minus 2 pi. We could have just even plus so you have this. So y will be equal to, you can factorize a out. When factorize a out, you are going to get the whole of this. You are going to get the whole of this. So you are going to get sine. We can factorize 2 pi out. So sine 2 pi. Please, I hope you are following. 2 pi into brackets. This will be vt
Yes, sir.
Honest. Plus sine 20 plus so that's what you are going to get. Hmm? So we can decide to uh, factor, but you know that vein all over, but we know that vein all over this is equal to f, and the f is also equal to 1 over t. I hope you know that. Mm.
Sir, please, the last equation. A bracket sine 2 pi
Pi into bracket vt all
times
over
Vt all over wavelength minus x all over
lambda
wavelength plus sine.
2 pi
From that part, I can see.
plus sine 2 pi into bracket vt all over lambda plus s all is the same thing, but it changes to positive. It's the same as this, but this sign here changes to positive because here is positive. You get it?
But you say plus sine.
Plus sine. I mean this plus, the plus is here. Yeah, it is a plus, but y2 is plus here. Have you got? Talk. I'm listening.
The last equation
So the last equation is plus sine 2 pi into bracket vt all over,
plus sine. I can't see the rest.
and I said it's the same as this. Repeat the same distance 2 pi this, but change the negative here to positive. Here. If you are following the equation, you should be able to know what I'm doing.
God punish physics.
Are you done writing?
Yes, sir.
Good. Can I clean it now? I want to.
Yes, sir. Is there, physics.
So, well, but you know that v all over this, v all over lambda is equal to f. The other day we established that the other day. F is also equal to 1 all over t. So in place of v all over this, we can substitute 1 all over t there. So we can come and get y is equal to. So you have this. Have you seen it? So yeah, we are going to use some trick identities to come and do it.
Won't TNT cancel?
Is it? No, in this case, they won't.
Because they all mean the same thing. And if TNT, and
Uh,
let's say they give time 2 seconds, the two cancel the two.
I won't. I won't. I won't. So when you have something like this, we are just doing the proving. So we are not.
Then
There's a small T and there's a big T. Let's just take it that way. I won't. When we solve questions, you understand. So uh, one is found in the angle and the other one is distant. So don't worry. Let's just. So when you have this from the trig equation, you know that when you have two sine, I've taught you trig, so I know I can confidently bring it here. When you have two sine a cos, two sines a cos, two sines a, two sine a cos b. When you have two sine a cos b is equal to sine into bracket a minus b plus a plus oh come on. So now I hope you've seen this trig function before. Have you seen this trig function before?
yes, sir.
Good. So you look at this trig function, compare this one to this one. Have you seen it? Compare this one to this one. Compare this one to this one. Compare this to this. Have you seen it? You realize that a minus b. So here, the whole of this will stand for a. The whole of this will stand for b. This and this two they are the same. So a and b. So we can say that a. Looking at the comparing, you can say that a is equal to a is equal to. But it is the whole of this is multiplying this because here there's no 2 pi. So we assume that 2 pi is multiplying the whole of that. So here will be 2 pi. So here will be 2 pi. A will be 2 pi. What do you call it? 2 pi small t all over 2 pi big T, period. Then look at this, B2 be equal to 2 pi x, 2 pi x, 2 pi x all over T. Sorry, all over, this one is all over lambda. I hope you've seen it. So compare the whole of this to this. You can say that A will be equal to 2 pi T all over big T, and B is equal to 2 pi x all over. For the purposes of the what do you call it, the proving, that is why we are not canceling anything. That is it. So just take it like that. So B is equal to 2 pi x all over lambda. I hope you've seen it. Or you have to compare this and this. Do you get it?
Yes, sir.
So we can humbly say that y will be equal to, we can humbly say that y is equal to, but don't forget that the whole of this is equal to this 2 sine A cos B. The whole of this is equal to 2a sine B. So if you agree that the whole of this is equal to this, then now we can humbly say that here will be 2a, this a will multiply this 2a sine, here the a is 2 pi t, all over t, cos B is do you agree? Check. So this will be our, what do you call it, stationary.
So why the small a?
And the small a is here. The small a is here. So if the whole of this is equal to this, then that means a will multiply the whole of this. Please, do you understand? Please, do you understand?
Yes, sir.
Good. So, so this will be the stationary wave. This is how the stationary wave looks like. This is how the stationary wave will look like. So if you are done writing, you just tell me. Are you done writing? Ruben, are you done?
So no, little wait a little more. I'm done.
Okay, so let's look out for some differences between, about 2 or 3 differences between progressive and stationary.
I'm done.
Now, So progressive, with the progressive waves, all the particles in the medium, all the particles in the medium, all the particles in the medium vibrate continuously with a progressive wave because they are moving. So all the particles vibrate continuously and are not permanently at rest. But normally with the stationary, particles at the nodes are permanently at rest. So with the stationary, realize that the particles at the nodes are permanently at rest. But that of the progressives, we don't have nodes and so on and so forth. So that of the progressive, all the particles in the medium vibrate continuously and are not permanently at rest. So one is not permanently at rest, but this one is normally at rest at the nodes. Do you understand? Do you get it? Huh? Ruben.
Yes, sir.
Okay. So now we also know that with a progressive, the maximum velocity of the particle occurs at the mean position. With a progressive, the maximum velocity of the
Yes,
particle
sir.
is another progressive. Another progressive, the maximum velocity of the particle occurs at the mean position. Another progressive, the maximum velocity of the particle occurs at the mean position. The maximum velocity of the particle occurs at the mean position. Whilst with the stationary, the maximum velocity of the particles occurs at the antinode. So you realize that the stationary, are talking about antinode here. So the progressive, the maximum velocity of the particles occurs at the mean position. And with the stationary, the maximum velocity of the particle occurs at the antinode. Occurs at the antinode. Are you there? Now the last one, with a progressive, the energy is transmitted continuously from one particle to another. With a progressive, energy is transmitted. Yeah, Ruben. 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 Ruben.
Yes, sir.
Oh, I've been shouting your name, sir. So let's do that.
Yes, sir.
With a progressive energy is transmitted continuously. Yes. Can you hear me now? Can you hear me now? Ruben. 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 Ruben.